Okay, this is section 12-4, and in this section we're going to talk about relative age dating and really how you do it. So this is what you would see in the rock record. Down here is F. This is the ending point, so this is what we would use to go back and look through geologic time to picture what was happening. So what you would do when you relatively age date your rocks, students will always want to start with the youngest and work towards the oldest, but it is much better to start at the oldest and work towards the youngest because that is the order the events are occurring. So if we looked here, my oldest event is going to be A because it's on the bottom. I'm just using the principle of superposition. Then B because B is above A, so B has to be younger than A. Then C. Then E. Then D, and then F. So for A through D, I use the principle of superposition. But F, I use the principle of cross-cutting relationships. Because F is an igneous intrusion, but it's cutting across everything. Since A is older than B, and it only shows up in F. Sorry. So since F would actually keep probably going, but you know A is older than B, and F only shows up in B, so F still has to be younger than A. And F cuts across everything through D. Therefore, whatever's doing the cutting is always younger than what is being cut. So F is younger than D. Then you have an unconformity, and it's in particular an angular unconformity. So on the test, you will have to tell me that that is an angular unconformity. So it makes the little squiggly lines, which, oh, they labeled it G. So G equals the angular unconformity. And then once again, going back, so you're using the principle of cross-cutting relationships because the unconformity is cutting across D, it has to be younger than D. So then, using superposition again, for H, it's on top, I is above it, and then J is above it. So, once again, these three are going to be superposition. These are the two primary principles you're going to be using to relatively age date your rocks. So that's superposition. And then you have the stream. And then so the youngest thing is the stream because you're using the principle of cross-cutting relationships. The stream is cutting across J, I, H, and into F. So the stream has to be younger than all these layers. So we know that. So this is the order from oldest to youngest. And if you would look back at the geologic sequence, it tells you the rock types. So it's telling you, basically there was an ocean depositing these rocks. This was land, so it went from terrestrial into the ocean. Then the environment changed from a depositional environment to an erosional environment, so D is getting eroded. Then an intrusion comes in. Oh, sorry, see, I didn't look up here. E is a sill. So I put it in here, let's see. E is actually younger. So I'm going to move E. See, this is why reading helps. So we're going to move E. E is actually younger than D, but older than F because it's being cut by F. Remember, a sill is an igneous intrusion, so it has to cut into it. So if it's a sill, that means that it's an igneous intrusion and it's cutting into it, and if D is present, if a layer is present above it, it has to be present. Otherwise, it would have been a lava flow and not a sill. Remember, a sill is an intrusion. It's a pluton. So the fact that it tells you it's a sill, it has to be younger because you're using the principle of cross-cutting relationships. So your sill intrudes, then your igneous intrusion cuts through. We're continuing, then we tilt the rocks because they're no longer flat. Then we continue to erode. Then the environment changes, one from erosional to depositional, and you start depositing terrestrial rocks again because you've got conglomerates going to marine rocks. and then this gets uplifted again and exposed, or sea level recedes, and now we have rivers, and the river cuts into it. So that's how you figure out the order. I have another one to kind of practice, just to show you. I recommend pausing and then doing it yourself, and I'm going to go through the explanation. So you can pause and then do it and then play again when you're done. So we're going from oldest to youngest again, but since I don't have space over there, I'm just going to do it along the bottom. Always start from the bottom. Students are very tempted to start with B because it's on the bottom. B is an igneous intrusion. It is cutting into F. There's also other clues that it's covering over this fault over here, so it has to be younger than that, even though the fault is cutting F. So the oldest unit is actually F. So we have F, and then we have A, because A is being cut across by B, and it's cutting across F. Oh wait, F is the fault. So I don't think they gave the metamorphic rock a letter, so we're going to just call it M. M is this right here. So M is this. M is this. So then it's M, A, because A is cutting across M, so A has to be younger than M. B is cutting across A, so B has to be younger than A. So then you look at F. F is cutting across B, so B is older than F. D is also cutting across B, so B is older than D. Whatever does the cutting is always youngest. So then we have an unconformity. This is actually going to be a nonconformity. It's a nonconformity because you have metamorphic rocks on the bottom and sedimentary rocks on top. The reason that D and F are younger than the conformity, because for one, they're cutting across the unconformity, so using the principle of cross-cutting relationships, and they go up higher. So then the next layer is going to be C, because it's the next one above the nonconformity, and F and D are cutting across it. The next one is going to be D. D cuts across C, but not into E. So then we're going to have E, and then finally F is going to be the youngest, because F cuts across all layers, including E. You can see the fault scarp right up here. And then if you wanted to label the little river, you could and make that the youngest. But that's the general order that the events are formed based on the principles of cross-cutting relationships. And I'm going to briefly talk about section 12.5 since I already talked about unconformities previously. So I'm just going to mention this. James Hutton, which is mostly considered the father of geology, recognized that the rock record is incomplete and there is missing time. So he was the one that really came up with the idea of unconformities, and that we are missing geologic time. And so what you're looking at here is an illustration of the famous locality that he used. So down here you have these layers that are dipping very strongly, and then these that are not dipping as much, and they're two different types of rocks. So A is Silurian age sandstone that dates to about 425 million years ago. Then you have the red sandstone, which is C, which dates about 345 million years ago. So there's a lot of time missing between there. There has to be an unconformity because these two layers are tilted completely differently. So A got tilted again when C got tilted, but A was tilted once before that. Then C was deposited horizontally on top of it, and then the whole thing was tilted again. And that's how he figured out that we are missing time.